Happy New Year, hello and welcome to FileFix, the 17th video as part of our Red Team Fundamentals mini-series. Up until now, we have discussed several mature techniques that could be leveraged to gain initial foothold onto our target system. And whilst those techniques still work and are indeed sufficient means of initial access, those techniques and ones similar are commonly educated across organizations. Given that phishing is an art itself, it therefore has various styles and ways it can be performed, and the technique that has recently been on the rise is named FileFix. As such, in this last video on initial access, we will discuss everything about it. As all of our videos, everything we teach in this video is purely for educational purposes. We take no responsibility for your actions. To understand FileFix, we have to take a step backwards to look at its older cousin, more specifically ClickFix. Throughout the year of 2025, one of the more common means of phishing was through the use of pretexting that involved leveraging common security implementations as a social engineering tactic. More specifically, an adversary would set up a web server that would use some basic JavaScript code, prompting the victim to pass a reCAPTCHA check. This check would be built in such a way that the pretext would request the user to prove their identity by running what appears to be a harmless command. However, in the background, the code would insert a malicious payload into the victim's clipboard, in addition to the padded out placeholder content. The victim is then instructed to paste it into the Windows run dialog and subsequently execute it. Now, because of the way the content appears when pasted in, it appears as if nothing malicious is present within the command. However, it is only until we scroll backwards a little, which bear in mind the victim would not be aware of at this point, that we would only find malicious commands. And since Windows only displays the end of the pasted content, an unsuspecting victim may perceive this as legitimate. However, this is far from the truth. FileFix is rather similar. There are several variations of FileFix and means of abuse. However, one specific variation leverages the fact that locally saved HTML documents do not apply mark of the web. More specifically, if an HTML document is saved manually by the user, rather than delivering it over some delivery means, that document will not be applied mark of the web. This means that if we can embed our document with malicious JavaScript that is capable of running system commands, it serves both as a greatly customizable means of pretexting, as well as an efficient technique of mark of the web evasion. For further reading, I will leave some articles by Mr. Docs on his blog site, where he explains the various techniques of FileFix he has discovered. I recommend you check it out after this video, as his explanations are far better than mine and go more in depth. After all, I believe Mr. Dogs is the original author of ClickFix and FileFix itself. Now, before we can actually leverage FileFix for payload delivery, we need some mechanism through which we will deliver payloads. As HTML files are recognized as web page documents by Windows, when launched, they are typically done so via a browser. And as browsers do not have the capability to interact with system-level components for launching other programs or commands, this significantly limits us in how we can leverage this technique. However, not all is lost. HTML applications, or HTAs for short, provide a framework that packages HTML technology into fully fledged self-contained applications that can run like any other program. Additionally, and perhaps most importantly, because with HTML, everything that occurs within a browser is sandboxed. This means that the browser has no direct access to the system besides its own memory. However, with HTML applications, as these are self-contained programs, they run outside the browser's context, meaning within their own allocation of system memory. Furthermore, as HTML applications have native support for languages such as JScript and VBScript, and because these languages provide support for frameworks such as ActiveX, which we'll get into shortly, we can leverage it to invoke COM objects that enable system command execution. Altogether, if we can distribute HTML applications via FileFix, we not only have a means of payload execution, but also a method of doing so whilst bypassing mark of the web. So what you're seeing now is some basic HTML application source code. And as you can see, we've got standard elements such as HTML, head, body, H2. And the way that HTML applications are built are the same way as with any other standard HTML document. Now, another element you'll notice is the HTA applications element. And this element essentially defines the properties of how the HTML application looks and how it behaves. Now, we went into the details of these elements in our mini course on initial access, for which you can find a link to down in the description below. But essentially, these properties allow us to configure the style of how our HTML application program looks, how it behaves. And some properties allow us to define values that allow us to launch HTML applications minimized, which I'll leave an exercise for you to explore. So let's actually save this file. I'll save it into the desktop directory. I'll just name it application. And the way we actually save HTML application programs is with the HTA extension. Now, with any standard HTML source file or document, we would save it as HTML. And by doing so, selecting save here, the file is saved. I'll open it up. And as you can see here, it opens up within the browser. And if you remember, anything that we execute within the source file of a HTML document is executed within the browser. Now, if we actually save this as a HTML application, rather than it being a HTML document, so use a HTA here, select save. You'll see that not only do we get a different icon now, when we launch the application, you'll see here it opens up in an entirely new window. Now, if we actually take a look at the task manager here, take a look at the running processes, you'll see that now instead of the browser, the process that is running our HTML application is the HTML application host. And this is the parent process for launching HTML applications. So you can see here our program, HTA Hello World, the title that we specified for the application is running as a child process. We can actually take a look at the properties here. You'll see that the program that is running is MSHTA. And this is the foundation or the framework for running HTML applications. Now, if we wanted to include some JavaScript code, we can simply use these script elements as any standard HTML document. And within these elements, we could define some JavaScript code. So as you can see here, we have a function named setBackgroundColor. And essentially what it's doing is accessing the document of the HTML application and changing the style of that document's body to the background color of pink. And as you can see here on the window on load event, so essentially when the application starts, we invoke this function, which should essentially set the background color to pink. So we can actually check this out. I'm going to save this, open up the application again. And as you can see here now, we have a background that is pink. So pretty straightforward. And as you can see, building HTML applications is as simple as building any other HTML website. Now, by default, there is no capability within JavaScript that exposes any functionality that enables us to run direct system commands. If this were the case, websites would suffer from severe vulnerabilities that would enable malware to execute malicious code. Instead, with HTML applications, we have access to JScript, which in turn provides us access to the ActiveX framework. Put simply, ActiveX is an old framework that enabled developers to create interactive web applications beyond what was achievable with standard HTML at the time. For instance, ActiveX could be used to host games, serve multimedia content and other functionality, all running entirely from a web browser. Additionally, and perhaps most importantly, from a red team perspective, ActiveX could be leveraged to interact with COM, and thus invoke COM objects that enable system level interaction. Now, one of these COM objects is WScript.Shell, which provides system scripting capabilities for both the JScript and VBScript. And this object exposes several methods, including one of them being run, which can be used to launch new system processes along with any additional command line arguments. And as you can see there in the syntax, all that it requires is the command the method runs, in addition to two optional arguments that can specify how the program window is displayed, in addition to whether the script should wait before proceeding to run anything else in the script. So if we go back into our HTML application, use new to create a new ActiveX object. And for its argument, we are going to specify WScript.Shell. And then through this object, we can use the run method to run any commands that we want. Now, in our case, I'm just going to run calc.exe to demonstrate how it works. And remember, the other two parameters were optional, so I'm just going to close it off and leave it as it is. So upon saving it and running the HTML application again, you'll see that calculator does indeed execute. And if we take a look at the task manager again, try to find the calculator process, you'll see that it is indeed running as a separate process. Now, although we can execute anything we like by simply using the run method of the WScript.Shell COM object, we still face a significant limitation. That is, most of the time we will typically want to execute some sort of C2 implant that would establish a session back to our C2 server. And whilst we could do this in memory through something like PowerShell, we can also do this by dropping a file onto the disk and executing it that way. Now, although we could use something like curl to fetch the remotely hosted implant and then create a new instance of the WScript.Shell COM objects to launch it, to avoid leaving common command line execution artifacts, we have another method which is far superior to this. And this method is simply by using a HTML application dropper payload. Now you can actually find this dropper payload on our GitHub repository, and we did actually build this in our mini course on initial access. And I won't go much into detail here, but essentially we initiate to other COM objects, and one of these COM objects allow us to initiate HTTP requests and receive its responses, and the other COM objects allows us to operate with data streams on the file system. So what we do here is we essentially fetch the payload using a HTTP GET request, and then take the server's response, which is hosting a Sliver implant, and then write that response to the disk as a file. And then because the implant we are serving is a DLL, we use the run DLL32 command to proxy its execution and thus establish a C2 implant session. Now, I know this can be quite a lot to take in, but for a better understanding, if you do want to understand this more, I recommend you go check out that mini course we have written on this subject. Now, in addition to the dropper, we will also need a phishing pretext. And I've created two of such pretexts. It's got shared file, we've got backup codes. And in the case of shared file, it leverages the capabilities of File Explorer in a similar manner as with ClickFix. But in our case, we will use backup codes. And essentially, this pretext will prompt the user to save the serving document, rename that document with the HTA extension, and then open that file to launch our embedded HTA dropper. Okay, so as we will be dropping a DLL implant onto the victim's disk, we will obviously need an implant to work with. And by using Sliver, we can generate one by using the generate command. I'll generate a beacon, specify the B switch for the HTTP communication protocol, then specify the host name of our C2 server endpoint, specify the F switch with the shared argument, which will specify that we are generating a DLL implant. And then optionally, you can use the S and the J switch to specify a custom time range for the callbacks of your implant to the C2 server. But in our case, we won't need this. We'll specify a lowercase s switch to specify the location of where we will be saving our implant. So I'll save it in the payloads directory. And once generated, I'm going to use SCP to transfer the DLL to our C2 server. Provided the password here. And then once transferred, I'm going to move it from the temp directory. I don't know why I moved it to the temp directory. Move it to the directory where we will be serving our content. And as you can see here, we have the 3 files we need in order to carry out a file fix attack. Okay, so once everything is in place, we will need to copy the dropper payload and insert it within our serving HTML document. Because remember, the victim will be browsing to the HTML document that they will save and rename as .hta. And in order for our HTA payload to be included and run, we need to embed it within it. Okay, so let's just modify backup codes.html, and you can paste in the script anywhere within the source file. And before we actually save it, there are several key properties that we need to modify. One of these properties is a variable named payload val, which will essentially contain the name of the payload. So I'll just remove the placeholder text and insert the name of our own Sliver implant. And then also we have payload URL, which will essentially specify the web server on which the implant is being hosted on. So we'll just leave everything as is, but we'll change the port to AT80, as port 80 is being used as our communications channel between the implant and the server. And that should be everything. So we can save this. And then before we actually serve the HTML document, I'm going to rename it from backup codes to index.html. And the reason that we are doing this is so that the user is correctly redirected to the pretexting document. Because if we leave it as backup codes.html, the victim will actually have to specify backup codes.html within the URL. And if we leave it as index, we can simply just send it the domain name. Okay, so once that's understood, I will simply start a new Python 3 HTTP server on port 8080. And once the user falls victim to our pretext, they will be redirected to the following web page. And essentially what it's asking for the victim to do is to save the backup codes. So we use Ctrl+S to save this page. Rename this page to 2FA backup codes 2025.hta. And the most important point here is the .hta extension. And then we are fooling the victim to open the file to confirm that the codes are correctly stored, where the HTA dropper payload should execute. Okay, so let's just copy this name of the file, use Ctrl+S to save it, rename it to 2FA backup codes.hta. Select save here, and once saved, the file should be within the downloads folder, the desktop folder, sorry. Now, if we actually select properties here, you'll see that mark of the web has indeed been stripped. And once the victim launches the HTML application, as you can see here, the application starts. And then if we take a look at the backend for our web server that is serving the payload and the pretext, you'll see that the HTML application made another request for the DLL implant. And then if we take a look at the server, you'll see that a new beacon session has been established. We can confirm this using the beacons command, and then use this beacon as we please, interact with it, etc. Now, one thing I want to note before we finish up is that once the victim saves this document, it must either be saved as web page complete or web page HTML only. And this is because of the content that Microsoft Edge and other browsers append to the saved file if they are not saved as either the web page complete or web page HTML only. So to illustrate this, let me just save it as web page single file. Select save here. You'll see the different extension that is appended to the file, even though it was manually saved as .hta. So let's actually take a look at the contents of this file. Choose another app, use a notepad to open it up. You'll see the different type of content that is appended. And this is not good when we are running HTA payloads, because our payloads will simply not execute. And if we did try to run this, you'll see that it opens up locally without executing any JavaScript at all. And once again, we go into detail why this happens within our mini course. So if you want to learn more about this, I recommend that you check it out. But because web page complete is the standard type that the file is saved as, we typically don't need to worry about this restriction. And that will do it for FileFix. I hope everything made sense, and hopefully now you can see how powerful this technique could be when properly executed. That said, in our next several videos, we will focus mainly on Sliver, where we last left off, discussing its capabilities in system navigation, enumeration, using third-party tools with Sliver, as well as other features of Sliver that any red team operator must know. Until then, feel free to join our Discord server where you can chat to us, contribute, explore our courses, and soon participate in labs entirely through Discord. And once again, I hope you found this video useful. Over and out.